2011 Chevy Traverse. Little history on this one. Had an engine performance code, and another shop, I believe, did the timing chain on it. I know at least once, maybe twice. I'm not sure the whole entire story. But when you start it and run it, especially when it sits for a while, it makes a rattling noise. When it's cold, like the timing chain's hitting something. But if you look at the codes here, do a full system scan, you go to report. In the ECM, they got engine position performance 1, bank 1, or engine position system performance bank 1. So it is a V6, so it's 2 banks. We'll see which bank 1 is. So we'll look at this code. I think we're gonna have to hook up the oscilloscope and compare cam and crank data, but we'll look up the code definition. They also have a P0455 evap large leak detected. I think they told them, the shop told them to put a gas cap on, but it came back. This is the concern here. This won't be bad. We can use a smoke machine here to figure that out, but this is the one we need to look at the definition, and go from there. Already, after going through some of that paperwork, it looks like what they did is they did a timing job one time. They replaced, that same code came back, so they replaced the variable valve timing solenoids. They had another engine light, so they replaced the gas cap. But obviously these are back. They're current DTCs. So let's go ahead and look up this definition. So I did check the oil, because that's crucial to these VVT systems, and oil level's good. And it looks pretty good as far as how clean it is. So P0008, engine system performance bank 1. Let's just see description operation. The ECM test for a misalignment between both camshafts on one bank of the engine and the crankshaft. So there's 2 camshafts and 1 crank, obviously. Checks for misalignment. The misalignment would be at an idler sprocket for either bank or the crankshaft. Once the ECM learns the position of both camshafts on one bank of the engine, the ECM compares the learned values to the reference value. The ECM will set the DTC if both learned values for the one bank of the engine are exceeding the calibrated threshold in the same direction. So then you look in here to set the code. The ECM detects both camshafts on either bank of the engine are misaligned with the crankshaft. That's why I think we need to scope it. Obviously check for any repairs, which another shop was in there. A single failed camshaft actuator solenoid will not cause this DT set. A single failed camshaft actuator or actuator solenoid will not cause this DTC to set. Now the other shop put in a camshaft actuator, and obviously that didn't fix it. You got to read, if they would have read service data, that would have not fixed it. It tells you right there. That's why reading SI service information is crucial. This diagnostic algorithm is designed to detect an alignment condition between primary, intermediate sprocket and the secondary timing chain, or the alignment between a primary, intermediate sprocket and the crankshaft. Either condition will cause the camshaft time for both cams on one bank. Either condition would cause the camshaft timing for both cams on one bank to be off an equal number of degrees. The presence of these DTCs, which you got the 008, indicates a possible condition with the primary timing chain and the alignment between both intermediate sprockets and the crankshaft, or the crankshaft reluctantly has moved and is no longer referenced to TDC, top dead center. Observe the desired intake camshaft position and the camshaft position parameters with a scan tool before a DTC sets. This may help isolate whether a condition is specific to one camshaft, one bank, or caused by condition with the primary crankshaft timing. Basically, you start it, you clear the code, you start it. You want to make the same conditions and make the code return. But we're going to go ahead and scope it. And then in here it talks about the diagram, how to align everything. However, we're not ripping that apart yet. What we're going to do is we're going to use an oscilloscope and see if our timing is off. We're going to go ahead and start it first, see if it makes a noise. This morning it's been sitting all weekend. Oh yeah, made a pretty good noise there. That was just from a little bit of lack of oil right away. So it got up into the valve train, but you can hear it rattling. The customer can hear it inside. Obviously your engine light's on. Let's look at the desired and actual now. Now that it idled down, you can even hear it a little bit more. I don't think it's picking it up on video quite, but you can definitely hear it rattling. Hopefully you guys can hear that. So with it idling, it wants 20%. Actually, I got to get this refigured out here. That's percent, that's degrees. Hang on one sec. Here's the right parameter. So it tells you in service data, observe the desired intake camshaft position. Because there's exhaust camshaft position, there's bank 1, there's bank 2. We're looking at bank 1, obviously, for the code definition. Here's the desired 0, and it's at 0 there, 1 there. I've seen it go up to 2 to 3 when I think I saw 4 once as well. But at idle, it's obviously going to desire 0. So we really need to drive it and rev it up and see what it does. Sorry about the glare, but you can see at idle here, the blue is what it wants, the green is changing them. I mean, I expect to change a little bit, but let's get it for a drive, take it for a drive and see what it does. I do want to erase the codes first, which I did, because that might prevent it from trying to move. Let's just reread them quick. So that's good. Let's go to our live data. Pull those 2 PIDs up again. It's only got 100 and almost 8,000 miles on it. Not bad. But I can definitely hear it. I don't know if you can hear it in the video, but I can hear it. So we want desired, and we want actual in degrees. Desired intake camshaft position, bank 1, and the actual position. See, once I clear the codes, and now it actually responds. Now, it wouldn't respond earlier because there was an active code in there. See, the blue is what it wants, and the green is what it is. So you can see it's kind of all over the place. It's not perfect, but it's not too bad. I'd have to look at the code criteria. Is it more than 2 degrees for so many seconds, or 5 degrees, or 18 degrees for so many seconds? But we're looking at is cam desired and cam actual for bank 1 intake. But that's why we need to scope it and look at the cam crank waveform to see if it's off in relation to that, and that's according to the service data, because it's a performance thing. You know, we're looking at desired versus actual. Right now it's pretty close. However, maybe, or actually according to service data, it's the cams in relation to the crank. So this may not help us. It is good data we can take and look at as well. But what we need to do is we need to hook up an oscilloscope to our cam, for sure bank 1 intake, and our exhaust. So pull up a wiring schematic diagram, look at that, and then hook up the scope and go from there. So you can see as I'm doing this, just steady state, it's changing a little bit. It's not perfect. There's a DXL. We'll look at the other ones here just as something to compare to and go from there. Again, we're going to take this with a grain of salt because we got to scope it to cams to the crank. We're just comparing cam to cam, desire versus actual. We need to do cam to crank with the scope. No, this is bank 2, desired and actual. Kind of look at this quick. All right, here we go. So it's about the same as the other one. Again, we need to scope it. And when we scope it, we got to take into account the variable valve timing solenoids. You know, whether we need to probably unhook them, we can get a capture that way. We can leave them hooked up, get a capture that way, but we need to definitely unhook them or limit them so they're not actuating to get a base timing with the oscilloscope, because the camshaft actuators are adjusting this and it's trying to compensate. Right now it looks, you know, pretty decent, but even said in service that it's trying to compensate for that. Look, it even says tighten gas cap. We'll talk about that in a minute. But it's trying to compensate for that. And, but it's not working, obviously. So that's why the engine computer's picking that up. That's why we've got to scope the cam to the crank. And then the other thing, we have to tighten a gas cap. They put a new gas cap in, but it doesn't mean it's a gas cap. We need to hook up with a smoke machine and see where the actual large leak is, or medium leak, whatever they had. I think it was a large leak. Take a look at that. But I want to get good evidence here before we, you know, pull it apart again, because that's kind of an expensive job to do, and they already did it once, the shop did. So we want to get some good evidence and data to prove exactly what is wrong with this car, and see if the customer wants to fix it, or they want to talk to the other shop, or what they want to do. But we got to get back to the shop and hook up our scope. So I just reread codes. 455 large evap leak came back up. Of course, tighten the gas cap. That's probably not the issue. We need to actually look at that if they want to go down that road later on. Something else. So I cleared the code, obviously, evap one again, but when I go to, so right there, P0008, engine system performance bank 1, it hasn't ran that test yet. That's additional. So we go to current codes, nothing. You know, the question is, why didn't the code come back right away? Well, if it didn't run its test yet and it didn't finish it, you know, you go over here, additional. If it's auto here and it's not over there, it's not acting up. This list is always refreshing. So let's just look and see if it ran its test yet again. Which I wish there was a actual search bar for this. But this P0008, it still hasn't ran its test, not run yet. I want to drive it again and see if it runs. If this runs and this goes away and it goes to the other side, then we know there's an issue with it. If it does go away and it doesn't go to the other side, then maybe it's just at a cold start issue when we're just starting up when it's cold. And that's one of their complaints too, which we still would want to scope it and look at it from there. So I just drove around the block a few more times. We'll go to current history codes, nothing. I don't hear that noise anymore right now. Sounds actually really good. So we're going to escape, we're going to go to additional codes, and you can see this bar is getting smaller over here. I don't know if you noticed that earlier in the video, but I don't see a P0008 in here no more, which means it did its test, and if it's not on the other side, I mean it passed for this part of it. I'm just verifying here. Like I said, I wish there was a search bar in this area, but it would have been in here by now. So that means it's passed its test. However, if we let it sit, it'll probably fail again. And that's where our issue is going to be, is at a cold start. And that's where I hear the noise. That's where the customer complaint is. I just heard some noise there a little bit. Obviously there is an issue. That's a B. We're still going to have to scope it though. The question is, we can get a scope capture now, but I think I want to let it cool off and also get a scope capture when it's cold. So that's what we're going to have to do. Capture it now when it's warm, and a scope capture when it's cold, and that'll help determine what we got going on here. Just restart it one more time. Read regular codes. And I believe that P0008 is a continuous, which means it's always looking for that. Non-continuous would be like an evap or something, which would have to have certain conditions met. Yeah, look, now that bar's smaller since we restarted it. So, right there, it's back in there. It hasn't ran yet. Eventually that'll go away as we refresh this and drive it. And obviously that code's picking up that the cam and crank timing is off at a certain time. And it seems to be, just from what we're looking at so far, is when it's cold. So let's get in the schematics and go from there. Also, when it's cold, we can do the, like we had the live data, we can compare it actuator when it's cold and see how spread out the graph is. That'll be some good data as well. Because right now you're looking at it, you're like, oh, there's nothing wrong. But we got to duplicate the concern or the conditions that put it in this fault. It even tells you that in service data. That's what we got to do. It's not right. I mean, looking at the data now, it looks like it's correct, but it's not. You can hear the noise when it's first cold. It randomly comes back. The cold will come back. That is not right. We got to, and I think it's going to come back when it's colder, which is not correct, right? We got to figure out why it's doing that, and is it worth to fix it? Then, of course, the question is going to come up, what about a cam crank relearn? We go into special function. I don't see nothing for a cam crank relearn. However, we could hook up the MDI2 and GDS2 and look at it that way too. We can actuate the solenoids like they already tried, but that's not the issue. The issue is there's an actual issue with the timing. Like it says, for this code to set, the computer detects that both camshafts, not one, but both camshafts on either bank of the engine are misaligned with the crankshaft. So it sounds like, am I looking there, there's a, bank, there's bank 1 and bank 2, or vice versa, whatever that one it is. I'll have to look to fire an order. There's exhaust cam and intake cam, exhaust cam and intake cam. For bank 1, exhaust cam and intake cam are misaligned with the crankshaft. That's the issue. And we could look at the exhaust side too, live data. So here's the exhaust side, desired and actual, for bank 1 still. Just the other camshaft. Just revving it up a little bit to see what we got here. So yeah, we'll get the schematics pulled up. And what's crucial is going to be a single failed camshaft actuator will not cause this. Okay, we know that. The diagnostic algorithm is designed to detect an alignment condition between the primary intermediate sprocket and the secondary timing chain, or the alignment between the primary intermediate sprocket and the crankshaft. Either condition would cause the camshaft timing for both cams on one bank to be off an equal number of degrees. And that's why we're using the scope. And it tells you to go the desired versus actual, which we did. We looked at bank 1. We could look at bank 2. Well, we did look at bank 2 a little bit on the intake side, not the exhaust side. But like I said, I think it's why is when it's cold is it doing it? But it's not doing it now, perhaps. However, It's a type B DTC. You know, is it oil pressure to a tensioner that's causing this, or what? And it's a type B DTC that sets for this P0008. So right here, type B, control module eliminates the male in the second consecutive ignition cycle. Not the first, but the second ignition cycle runs and fails. And it records it. We could have got the mode or the freeze frame data. We already cleared it though, but it'll eventually come back on when we run it. Yeah, 2 consecutive trips. So it's got to fail basically twice or 2 trips. So maybe that's why, you know, also why it's not coming on right away. Just another thing. Maybe it's not when it's, you know, it seems like it's worse when it's cold, but it's got to have 2 trips for it to come on. Just some parameters, because it is a type B. Less for field trim codes there. You can read through all this. So yeah, let's pull up schematics. See, it even tells you operate the vehicle within conditions to set the DTC. You may also operate the vehicle within the conditions that you've seen from the freeze frame, which we will look at next time when it throws it. You know, and maybe that is only when it's cold, perhaps. Make sure they're not misaligned. The reluctor's not misaligned. You know, they were just in there, so we gotta look at all that. Alright, so here's the wiring schematic, your engine computer. Here's your crankshaft position, and your cam positions are all Hall effect sensors. Got 5 volts coming into it. Here's your crank. There's camshaft sensor, bank 1 intake, bank 1 exhaust, bank 2 intake, bank 2 exhaust. So I want to scope the crank and this cam and this cam. We could scope these two if we needed to. But there's 4 cams and 1 crank, obviously, and sensor on each damn one. So we want to scope that and check that out. And we're going to go to the X1 pin 35 connector for the crank, the X1 pin 7, and pin 34 for those. And then we can go to these 33 and 9 if we need to for bank 2. Now, I found this service bulletin, or PIP they call it. He's got a P0008. This is just some informational here. See if it applies to this car. Which it does. Make sure I'm on the right year again. Yes, 11 Traverse, 9 to 14 Traverse. Vehicles with 3.6 may exhibit 2 or more of the following DTCs. We only have 1, P0008. If the above concern is present, check for loose timing chains or tensioners. Well, that sure does what it sounds like, huh? All that chattering. After the service information diagnostics of the root cause is not found, which we're still going through that, right? We're looking at all that still. See what we can come up with. The following may be helpful. The reluctor for the crankshaft sensor pressed on the crankshaft may have moved. Refer to the attached photographs for exact location. It is possible on some applications to do this with a borescope through the crankshaft sensor hole without removing the oil pan. If the reluctor has moved, replace the crankshaft. We only have 1 code though. However, we need to go down this information of scoping it when it's warm and cold. And if it's cold, you know, the tensioner is loose or something, then that would eliminate this whole thing, this PIP here, service bulletin. And that would make more sense why it's doing it when it's first cold and gets better. Is it not installed correctly? Is it oil delivery system, or what's going on with that? But if, say, that is good, then we want to look at this reluctor and make sure it hasn't moved. It tells you all the specifications there. But we would see this on the oscilloscope if this was off. So this, if this was actually off, we would see that by scoping this. So let's hook up the scope next. Alrighty, so I got the scope hooked up right at the ECM X1 connector. My red is my crank. My green is a cam and my blue is a cam. Red crank, green is my intake cam 1, bank 1 I mean. And my blue is my exhaust bank 1 cam. So crank, and then bank 1, crank, bank 1 intake, bank 1 exhaust. And we didn't do bank 2 yet. Now we're just at idle. I want to capture these, compared to a known good one. We're at idle. We should have no actuator movement. We may have to unplug the actuators just to eliminate that variable, or make sure they're commanded off, compared to a good one. We're going to have to do this now it's warm. We're going to have to also do this when it's cold and see what we get. So I saved that waveform. Now we're going to do another one, clear flood crank. We had it one at idle we just saved, and we're going to clear flood crank it. Just cranking. Clear flood crank, just cranking. Actually, let me change my time base for that. I went the wrong way. Get more data. So we'll save that one next. We pause while I save all this stuff. There, I saved all those. So what we can do now is we can go back into our oscilloscope. Sorry about the glare. I got one engine crank, our engine idling and engine cranking. The VVTs are not unplugged. They should not be actuated. We might have to go down that road too once we can find it known good. And again, this is with the engine warm. We have to redo this when it sits for a few hours when it's cold to actually find our issue. So let's open the waveform. So here's the cranky one I just saved. Here's the idle one. So A sensor, it tells you my sensors. I label them all according to our sheet. So we'll open this up. Red is crank, green is intake cam bank 1, and blue is exhaust cam bank 1. And now we can compare this data and put our cursors in and all the stuff. However, like I said, we need to find a known good one in a waveform library. I'll look, and we also need to do this when it's cold. We may need to do bank 2, but the only reason I'm doing bank 1 now is because we have a system performance on bank 1, and that's how we have to approach this. All right, so we scoped it. So here's a known good one. And this is your crank, your intake cam, and your exhaust cam. Here's ours, crank, intake cam, exhaust cam on bank 1. I do want to do bank 2, and I'll tell you why in a minute. But before I talk about that, or the scope patterns, apparently this had 2 timing sets in. It had a timing set in, and then it came back to the customer. They put another timing set in. I'm not going to get to all the fine details of that. I just know that 2 timing sets have been done in this. So this is from a 12. This is from 11. Idle known good, 37,000 miles. This one's idle known. It's unknown, right? But I'm going to show you that it is bad. I'm putting a cursor on the falling edge of this and the falling edge of that. And on the bottom there, we got 3 teeth. And we're doing the same thing here. Falling. We got 2 teeth. 6.331 milliseconds difference, or delta, 4.58. So a couple milliseconds off. You go to the top. Between the cursors, there's 4. Go to the top, Between the cursors, there's 3. On the bottom, there's 3. On the bottom, there's 2. The pattern's the same. Boom, boom, boom. Boom, boom, boom. Come over here. This rising edge is going in the center of that. We can measure that. This rising edge should be to the center of that. This whole thing should be shifted over in relation to the crank. Now let's check our cam to cam. So what I'm getting at is 3 and 2. We are exactly 1 tooth off on the crank. I'm assuming the cams will be in time. According to the service data, we'll look at that. We're 1 tooth off on the crank. Good, bad. Now, is it both? So this is bank 1. Now, if it's just this one, it was put together wrong with the wrong, timing when they're a tooth off. Or is it both banks? We can scope bank 2, and is this pip applied, this TSB, where the crank thing shifted? We'll eliminate that or prove that with our scope and bank 2 as well. But we are definitely 1 tooth off on the crank. Now let's just check cam to cam. But before we do that, we'll put a cursor here on the falling edge, a rising edge, and over, come on camera, focus. We'll put a cursor, focus. We'll put a cursor right there, and we got a difference of 1.899, almost 2 milliseconds, 1.9. Same thing. Should let me zoom in on this one to redo our cursor. A bit close. You can visually see it's a tooth off. Yeah, 0.69. I had 0.8. It depends where I put my cursors. I'm trying to get them snapped in this place. But either way, you can see that this is in the center of that pretty much. This should be in the center, and it's not. So now we know it's 1 tooth off. Let's check our intake to our exhaust cam. So here to here, 14.56. Here to here, 14.5. Same thing, right? So our cam to cam is 100% on. Our bank 1 intake cam to cam is 100% on, but our crank to cam is 100% 1 tooth off on bank 1. Now what I want to do is check bank 2 and make sure this pip doesn't apply. Alrighty, I'm on bank 2 now, intake, exhaust, and cam. Sorry, crank, intake, exhaust, all bank 2. So we'll go ahead and read it. I got the good one pulled up and we'll compare it here. I'm not going to save this one, there's no need to. I'm just going to compare it real quick. See if that'll take us to that pip or away from it. Or it may not even be that, maybe they put them both together wrong. We'll take a look here. Alright, so bank 2, we have issues as well. I'm doing cam to cam, intake to exhaust, intake to exhaust. Difference of 7, there's 7.47 is your delta. We got 7, so 0.747 milliseconds off. Cam to cam. So there's something wrong with that. If you look, this edge right here comes pretty close to that edge. Well, we're off right there. So let me put these cursors in here and show you that another way. Yeah, so the difference is 605 microseconds. And over here, so I'm trying to film and do this at the same time. There's my finger. Alright, so we're going to go, it's already off, it's already shifted the other way. This should be this way, we're on the other side. So we proved the cam on bank 2 is definitely off. Now let's look the cam the crank. Now cam the crank, we're 5.3, 4.2. So we're off there. Looks like we got 3.5 teeth in there. And 2 teeth in there on the bottom. Up top we got 4.5. Up top we got 3. So right here on the bottom we got, cursors aren't perfect, but 3.5 on the known good. We'll call it 3. Here we call it 2. So definitely a tooth off on the crank to bank 2 as well. And the cam on this is off. Now the question is, did they put it together wrong? Sure looks like it, right? For timing. Or does this pip apply where we gotta look at that crank? But what I would do, since we're gonna pull it apart, to do the timing, I would look in there, make sure the timing's right, and I would also look at this preliminary information, the service bulletin, to make sure. Make sure there's no loose timing chains or tensioners, which we have to go in there. We have some noise. If you follow the service information, it's not found. You want to look at this and see if this is off. All right, so I'm going to wrap this video up. We know, in fact, bank 1 and bank 2 is off on the crank to cam, and bank 2, the cam is off as well a little bit. Now, was it put together wrong, or was it where this reluctor wheel moved on the shaft? And if it did, you'd have to replace the crankshaft. However, what we'd have to do, it's going to be up to the customer, is we take all this apart and look at it, retime it, then we can look at the crank. If we retime it, it's off, we're good to go. If we take it apart and the reluctor moved, then we need a new crank or a new engine at that point. But when the shop initially did this job, once or twice in this case, it seems like, that should have been addressed and looked at per the service bulletin. It's always a good idea to look at service bulletins anytime you get a code. Always look that up, because now, we could have eliminated that or fallen that problem. I'm not saying that is the problem, but we know that it is 100% off. You just want to get, the more information, the better. We got to talk to the customer and see if he wants us to look at it farther, rip it apart, or if he wants to take it back to the shop. Now we got good, solid data that it is indeed off. So that is it for this video.